Hello everyone, this video clip is going to be on Unit 9, which is about nonparametric statistics. It's going to be a quick summary on how to pick the test for nonparametric statistics. Okay. For the nonparametric statistics, well, before this, in chapter unit 4 or 5, what we did is for parametric statistics because it's about the data, which is quantitative, the new data with number, and then those data are based on the normal distribution assumption. So for nonparametric statistics, because sometimes in the real world our data may not be distributed normally, so in that case we cannot use the regular parametric testing like hypothesis testing in chapter 5 that we did before, like C-test, T-test that we did. So for nonparametric statistics, it's a broadcast of statistical methods that we do not assume a specific probability distribution for the data. So we don't need a normal distribution of the data. As I said, for parametric methods in hypothesis testing in chapter 5, it relies on the assumptions about for example, we need normal distribution, right, for the data. Okay, data has to be normally distributed so that we can pick the test in case 1, case 2, case 3 that we did before. But for non-parametric methods, these methods are more flexible and it can be applied to the data that don't need the requirement or assumption for a normal distribution. Okay, so parametric, it's more like stricter requirement than non-parametric test, and for parametric test it make a stronger inference of the data. So for non-parametric it's better, but it might be less reliable than parametric methods. Okay, so the key characteristic for non-parametric statistics are this. For non-parametric tests, they do not require the data to follow any probability distribution. So the data don't need to be normally distributed or don't like binomial or whatever. We don't need distribution for the data in order to do the non-parametric test. And they can the non-parametric test, they can be used with the data measured at nominal. Nominal means, I will talk about the type of the data on the next slide. Nominal data means categorical data or qualitative data, and or ordinal data means the data that you can rank, like the customer satisfactory score, like rank from high level until low from low to high, something like that, that you can rank the levels. It may not be number, but you can rank. Okay, and also with interval or ratio data. Okay, and when the parametric assumptions are not satisfied, usually interval or ratio data, if we have this type of data, usually we do parametric tests because they are numbers, or interval or ratio, they are numbers. But in the case that the assumption for parametric tests are fail, like they are not normally distributed, or the size is too small, something like that, then we can use non-parametric test for it. for them too. Let me underline. Okay. In case the assumption are satisfied, then we use parametric. But if the assumptions for parametric are not satisfied, then we use non-parametric test for interval or ratio data. And for non-parametric test, it is robust to the outliers, means it is reliable. If your data has outliers, then the test it's more reliable than parametric test. Robust to outlier and skew distribution, okay, which is suitable for real-world data that are not perfectly normal. All right. Sample size. The non-parametric test, it is really useful with small sample. Okay, small sample size, because sometimes it is difficult to find a big sample size. Okay, in this case, for the test, we may consider the non-parametric test instead of parametric test. Okay. Okay, let's see the difference between parametric and non-parametric methods. All right, parametric methods, it's what we did before. Okay, in hypothesis testing, we did C-test, T-test. Actually, there are more like regression and ANOVA, and also correlation that we did Pearson. It's also parametric in parametric methods. Okay, compare the meaning. For parametric methods, it's a statistical test, which is we need assumptions about the population parameters. Usually we need normal distributions for the population. And on the other hand, for non-parametric methods, it's the test that used in case of non-metric independent variables. Okay, and we don't need assumption on distribution. Okay, here assumption normal, make few or no assumptions. Data type. For parametric methods, the data type that we need is interval or ratio. I will talk about it later. And for non-parametric methods, it can be nominal, ordinal, and it could be interval or ratio that do not meet the assumption for parametric methods. Okay. And measure of central tendency. Usually for parametric methods, we test for the mean, right? We test for the value of the mean may be equal to some number or greater or less than some certain number. But for non-parametric methods, we use median, right? If the data is skewed like to the left and or to the right, then the central value that we should use, remember from chapter 2, unit 2, it's median, right? Median is reliable if your data is like has outliers or skewed. And sensitivity to outliers. For parametric methods, it's really sensitive because we use mean. If there is like one outlier, then it could change the mean. For non-parametric methods, we use median, so it is less sensitive and more robust. And for parametric method, usually it is more powerful when the assumption for parametric methods are met. If we can use parametric methods, then it's really good. It's more powerful and more reliable. But if we cannot use, then we have to use non-parametric methods. then it is acceptable to, even though it's less powerful, but we get the flexibility. All right. For example, with parametric methods, we do t-test, z-test, t-test, z-test for normal distribution. And also we have not done this, but it's ANOVA, analysis of variance. And we did this. We use to compare the association of the data. We have Pearson correlation. For non-parametric methods or tests, we have Mann-Whitney-U, Kruskal-Wallis, Wilcoxon, Spears-Monroe. Spears-Mann is correlation. This is a test for association here, and up here is the test for the difference, just like z-test, t-test, or ANOVA. All right. Now let's see the type of the data that I talk about. We have interval, ratio, nominal, ordinal. What are they? Let's see the types of data and non-parametric test. All right. When we pick a statistical test, it depends heavily on the type of the data you are analyzing. Okay, it depends on the type, like are they number or not number? They are qualitative, quantitative. For qualitative, we have we have subtypes of the data as well. So let's see the meaning of each type. In statistics, the data are typically categorized as nominal, ordinal, interval, or ratio. But in some book, they might categorize as nominal, ordinal, discrete, or continuous. So it depends. But usually there are 4 types like this. So non-parametric tests are useful for nominal and ordinal data. Okay. And also useful for interval and ratio. These are numbers, okay, data with number that do not meet, okay, I say that do not meet parametric test assumption. Okay, if they fail to meet the parametric test assumption, then you can use non-parametric test for it. But if the interval or ratio data, if they meet the assumption for parametric, then you go for parametric. That's better. Okay. Now let's see the first one, nominal data. Okay. What is it? Nominal data. It is data that represent categories without any order or ranking. On the other word is that it's categorical data. Okay, categorical data. That without any order or rank, you cannot rank them. Okay, for examples, gender, male, female, you cannot rank them, and they are categorical data or qualitative data, right? Categorical or qualitative. Okay. See, you cannot rank this. Or blood type A, B, or O, you cannot rank them, right? You cannot rank them in order. So these are nominal data, or marital status, like single, married, divorced, something like that you cannot rank them. So key feature is here, no ranking or meaningful quantitative difference between categories. Okay, we call this nominal data. Now next, for ordinal data. Ordinal data is the data with a meaningful order. Okay, ordinal means order. okay, means you can rank them, okay. Data with meaningful order, okay, data with order or ranking. But the intervals between values are not necessarily equal. For example, the survey responses, for example, we have give out a survey, and the scale is like strongly agree, neutral, or disagree. Don't have to be number, but here you can rank them, right? Strongly disagree might be on the right side and strongly agree on the left side, and you can order them, okay, rank them in order. Or education level, you can rank them like elementary is the lowest, and then high school, undergrad, postgraduate, something like that. So there are there are categorical data that can be ranked, okay. And the key feature is that you can say one is higher or lower than another. Means you can rank them or arrange them in order. We call this ordinal data, okay. They are qualitative or categorical data that can be ranked. Next, the other type is the third type, interval data, okay. Interval data, the data with number, right? Numeric data, okay. They are number. See, with number you can do a parametric test, okay. It's numeric data with equal intervals between values, but no true 0 point. What does it mean? For example, the temperature in Celsius or Fahrenheit, or IQ score, just like temperature in Celsius, equal interval between values. For it means like if you say temperature, the difference of 50 degree Celsius and 30 degrees Celsius, okay, the interval will be 20, right? 20 degrees Celsius interval. And it's gonna be the same as you say, okay, 100 degrees Celsius and 70 degrees Celsius. Also, oops, sorry, should be 80 degrees Celsius. Then the difference is 20 degrees Celsius interval as well. So they have the equal interval, okay, something like this, between values, but no true 0 point, okay. Like 0 may have no meaning, like 0 may not be like nothing, it could be something, no true 0 point. Key feature, the differences between values are meaningful, but the ratio are not. Like it say the ratio are not means we can't say 20 degree is twice as hot as 10 degree. So you cannot say 20 degrees is like twice as warm as, or twice as cold as warm, right? As 10 degrees. So you cannot say that. You cannot go by ratio. Or like 50 degree is like 5 times as hot as 10 degree. No, you cannot say that. So the ratio are not meaningful for the interval data, but the interval are equal even though the numbers are different here. So number 4, the ratio data. Ratio data is also numeric data, okay, with equal intervals, and we have true 0 here, true 0 point, okay. For example, the height, the weight, the age, incomes. This is what we did in parametric test. We do ratio and interval data for parametric test, okay. Test score, 0 means nothing, right? 0 means total absence, or zero height mean you don't have height at all. Weight, zero age, newborn. Or income, zero means no income. Okay. For interval data, zero may not be like nothing, like 0 degrees Celsius doesn't represent like no temperature, something like that. It means something like freezing point. So for ratio data, both differences in ratio are meaningful. Like when you say 4 meters is twice as tall as 2 meters, that's true, right? Twice as tall. So the ratio are meaningful for this. We call ratio data. And note that there are two broad types, as I said. For quantitative data, they can split out as discrete and continuous, or they can split out as interval and ratio. But more likely, people split out in this way for hypothesis testing. See, this is a chart. So type of data, you have qualitative and quantitative. For qualitative, we have nominal data that cannot be ranked, and ordinal data that you can rank the data. Okay. And for quantitative, we have interval and ratio. Okay. Now, why are we doing this? Because when we pick a test for non-parametric, we need to look at the data, consider the type of the data. For nominal data that cannot be ranked, okay, or ordered, we have some tests that design for this type of data, non-parametric tests. For ordinal data, we also use non-parametric tests because they are not number, right? You cannot use parametric tests. You cannot compare the mean, okay? And for interval or ratio data, we use the non-parametric test only if the data are not normally distributed or the sample size is small. But if the data are normally distributed, then we use parametric. Parametric. Okay, test. All right. So here are examples for nominal data. For example, blood type, gender, marital status that I've said before. We use chi-square test, Fisher's exact test, ordinal data. We have tests here, and interval or ratio when the data are not normally distributed or the assumption for parametric are not met, then we use this test. Here are the chart, like the whole chart. Actually, there are more here, ANOVA, for more than 2 samples. Okay, for hypothesis test in statistics, for parametric test with interval or ratio, right? Interval and ratio that meet the requirement. So we have tests for 1 sample and 2 sample, and more than 2 samples we have ANOVA on the next page. For 1 sample that we did, t-test, c-test, we did just only this in chapter 5. And for 2 samples, actually we can do, for independent sample, we have c-test as well and 2 group t-test. And for paired sample, we have paired t-tests, okay? For non-parametric tests, also have 1 sample, 2 sample, and actually more than 2. We have more tests on the next page. So chi-square that we did a lot, and also for independent chi-square, Mann-Whitney, sine, Wilcoxon, chi-square. That's it, okay? All right, here more, okay, more in detail here. if you want to do see classification of hypothesis test, you see type of the test here, parametric and non-parametric. So the level of measure, for parametric test, we do interval or ratio data, right? With interval or ratio data, with one sample, we do C-test or T-test. For two samples, it's split out into two groups, independent data and dependent data. For independent data, we use sample t-test. For dependent data, we use paired sample t-test. Now, for more than two samples, for independent samples, we do one-way ANOVA, analysis of variance. And for dependent data, with more than two samples, we do repeated measure ANOVA. And also we have correlation. Here is upfront are the tests for to check for the difference. Okay, we compare the mean, right? And we also can also compare the association. So we do correlation here, and we can do Pearson's R test, okay, to check the correlation between the data. Now, for non-parametric tests, we have two types, categorical or nominal type, okay, and ordinal type. So for a nominal, split out here one sample, you use chi-square, and ordinal can do chi-square as well. For two samples, we have chi-square. For nominal. For ordinal, you have Mann-Whitney U test. And okay, I'm gonna circle this here that we use. We see a lot here, okay. Q test. For dependent data groups, for two samples. For nominal, okay, we do this test, and for ordinal, we do this Wilcoxon. Here you might see this a lot. Okay, they use a lot. And for more than two samples, we have here. For independent and for dependent, we have Cochrane Q test and Friedman's test. And for correlation, for non-parametric test, we have Spearman the row test, right? And more detail here that you can read. Okay, I put more detail, so actually they are the same. So more detail here with example. For one sample, for example, here, if you have one sample, this is for non-parametric test. So down here, the pink one, okay? For non-parametric test, if you want to compare, for example, patient outcomes to a known median, okay? You want to compare the median for one sample, then you might use sign test and Wilcoxon one sample, and sometimes chi-square test. So detail is right here. You can read them out here in detail. I put scenario here for you to read right here, so you can read them in more detail. It's the same as the table here. And for two independent samples, means your sample are not rely on one another. So you want, for example, you want to compare the exam scores between two teaching methods. There are different methods, okay, with two different group of students. Then you need to use this test, Mann-Whitney U. Now for this is for ordinal data. For two independent sample and with nominal data, okay, this one up here, you can order, no order. You want to test association between smoking and disease status, then you use chi-square test. Now for two dependent or pair, they call it pair samples, okay, pair t-test, pair test. Two dependent samples means the sample, sometimes the sample, you use the same group of people or sample, like you do blood pressure before and after medication with the same patients, the same group of patients, but you apply medication before you apply medication and after you apply medication. So in this type of sample, we call dependent, right? Because it's the same people, same group of people. In this case, you use Wilcoxon signed rank. Again, and another one is two dependent, also pair test with direction. Like you want to see the difference, productivity before and after the workflow. Is it better? Is it not better, like getting worse? So you do a sign test. Sign test is a test for the difference. For example, you want to look at the difference between median, okay, of the two groups, okay. And for more than two samples, we have independent, dependent, and binary, okay. So the tests are like these three tests. You can read more in detail here. Binary means we have either the answer or yes or no, like allergy improvement, improve or not, with 3 treatments in sample, like that. 3 treatments in samples mean you have 3 groups, okay. So more than 2. And binary means you can go with yes or no, just 2 types. So in this case, we use Cochrane's Q test, right? All right, you can read more detail in here, so I will not go in detail here because it's gonna be too long. So you guys can read a little bit more. So in the exam, I'm gonna ask you like which test to use for which type of samples, or might have scenario, and then you can pick your test, but we will not go deep in detail like how to test it, okay. All right, I'm gonna end the clip here, and you guys can continue reading on the examples. Okay, thank you. Bye.